Assalamu alaikum. Hello everyone. We are going to talk about such an important topic from thermodynamics course, which is properties of a pure substance. I'm gonna start with the ideal gas equation of a state. So let's move immediately to the first example. Determine the mass of the air in a room whose dimensions are 4 meter multiplied by 5 meter multiplied by 6 meter at 100 kilopascal and 25 Celsius.
The solution. From the question, we have the volume, which is 4 multiply 5 multiply 6 is equal 120 meter cube, and we have the pressure, which is 100 kilopascal, and the temperature is 25 Celsius plus 273 is equal 298 Kelvin. To find the R, from the table A1 we can find R, which is equal 0.287 kilopascal meter cube per kilogram Kelvin. So the mass of the air in the room from the ideal gas relation is to be PV equal mRT. V is the pressure, V is volume, and M is the mass, R from the table, and the T is the temperature. So we have the pressure and the volume, and we have the R from the table, and we have the temperature from the question. So we need to find the mass. Then we can say that M equal the pressure multiply the volume by the temperature multiply the R. As we can see, the M equal 100 kilopascal multiply 120 meter cube by 0.2087 kilopascal meter cube per kilogram Kelvin multiply 298 Kelvin. So the mass of the air in the room is equal 140.3 kilogram.
Pressure of saturated liquid in a tank. A rigid tank contains 50 kilograms of saturated liquid water at 90 Celsius. Determine the pressure in the tank and the volume of the tank. A rigid tank contains saturated liquid water with a mass of 50 kilograms and temperature of 90 Celsius, and we have to determine the pressure, also the volume, by using the equation of volume equals mass multiplied by specific volume.
So after we understand the question and what we have got and what we need more information, so since saturated condition exists in the tank, the pressure must be saturated pressure at 90 degrees Celsius. So we are going to use table A4 to identify the pressure. So after we look at the temperature is 90 degree, we will find the pressure 70.83 kilopascal, and for the second things is the volume. We can identify the specific volume from the table, and the specific volume is 0.001036 meter cube divided by kilogram. So if we multiply this number by 50 is the mass, we will get the total volume of the tank 0.0518 meter cube.
And now we will talk about the use of steam table to determine properties. So we have this question, which is determine the missing properties and the phase descriptions in the following table for water. Also, we can see here in the table that T is the temperature, P is the pressure, U is the internal energy, X is the quality and phase description. Also we have A, B, C, D and E. In A, we will know that P is equal to 200 kilopascal and X is equal to 0.6, which implies that 60% of the mass is in the vapor phase and remaining 40% is in the liquid phase. Therefore, we will have a saturated liquid vapor mixture, so we can call the phase is mix. After that, we will go to table A5 and we will find the T, which is 120.21 Celsius. At 200 kilopascal, we will find UF and UFG from table A5. UF is equal to 504.50 and UFG is equal to 2024.6, and we can use it as follow. U is equal to 504.50 plus 0.6, 2024.6, which is equal to 1719.2 kilojoule per kilogram. In B, we know that T is equal 125 Celsius and U is equal to 1600 kilojoule per kilogram. So first we will go to table A4 in order to determine the phase description. And we will find UF, which is 524.83, and UG, which is 2534.3. And we will find that U is greater than UF and less than UG, so that the phase is mixture. After that, we will also go to table A4 and we will find the P, which is 232.23 kilopascal. After that, we want to find the X. So we have U and UF and UFG, and we can use it as follow. We will say 1600 is equal to 524.83 plus X multiplied by 2009.5, and so that the X is equal to 0.535. In C, we know that P is equal 1000 kilopascal and U is equal 2950 kilojoule per kilogram. So first we will go to table A4 in order to find UG, which is equal to 2582.8. So we will find that U is greater than UG, so that the phase is superheated vapor. After that, we will leave the quality column blank in this case, since it has no meaning for a superheated vapor. So we will say that X is not found. Finally, we will determine the temperature by using interpolation, and we will find that T is equal to 395.2 Celsius.
In D, the temperature is given by 75 Celsius and pressure is equal to 500 kilopascal. From the saturated steam tables, we are going to obtain the saturated temperature at 500 kilopascal, which will give us 151.83 Celsius as a saturated temperature. Since the saturated temperature is more than 75 Celsius, it will be compressed liquid, and from the steam tables we will find that U is equal UF at 75 Celsius, which is equal to 313.99. We know that X is equal to 0 and the pressure is equal to 850 kilopascal, so the phase is going to be a saturated liquid. We need to go to table A5 to find the result of the U, which is equal to 731 kilojoule per kilogram, which is also equal to the UF at 850 kilopascal, and the temperature is going to be 172.94 Celsius, which is also equal to the saturated temperature at 850 kilopascal. Finally, we hope that we have succeeded in presenting this topic in a simple and smooth way, and we also want to thank Dr. Sami Al-Ghazali for his instructions and advices related to this topic. Thank you for watching.